On to the next. So let's actually try to solve a linear equation. So remember, our job is to solve for v here. Okay? And what we need to do is basically get v by itself, right? Because remember, when we said solve, solving means to find a solution. A solution to this equation is going to mean some v is going to equal, make this statement true. And how do we find that? Well, if I have v over 9 and that's equal to 9, now there's a couple of ways you can do this. I'll show you the way that I would do this initially. The way I would solve for this initially would be to multiply by 9 on both sides. Again, so this is like this is just my initial way of doing it. I'm gonna actually do this in different ways. Okay, so how do I do this, right? If I take 9, I multiply this by both terms, right? I multiply by this and I multiply by that. So I have v times 9 over 9, and that's going to equal to 9 times 9. So I'm just distributing this to both terms, right? This is how I would do it, but just bear with me. Okay, so in a fraction like this, you have something in the numerator that's equal to the denominator, they cancel out. So I have a 9 on the top and a 9 on the bottom. I'm left with just v. And v, as you can see, I've already solved the equation. I just need to figure out what's on the other side because I have the variable by itself. This is going to equal to 81. Okay, so that's the solution to this linear equation. So we solved the linear equation. Okay, so that's this linear equation. Next one would be 2 plus x equals 9. All right, well, let's see here. What would I do here? Well, again, I want to solve for x, right? That's my job. That's how I'm going to solve this equation, by getting x by itself. Well, you have to look around what's around x, right? If I need it by itself, that means there's other things with it right now. You see, it's not solved right now. I have this plus 2 here. So it's written 2 plus x. Well, you'll actually learn about numbers is the fact that they are commutative. And what commutative means is that you can add two numbers in any way you want. What does that mean? Well, 2 plus, I don't know the answer. Let's say x, let's just say 3, right? 2 plus 3 is the same as 3 plus 2. So I'm going to use that commutative property to rewrite this equation down here. And I'm going to write it like so. X plus 2 is equal to 2 plus x, and that's equal to 9. All right, so if I have x plus 2 is equal to 9, all I need to do is solve for x by doing the opposite of what plus 2 is. Well, the opposite of plus 2 is minus 2. So I'm going to take x plus 2 and minus 2. But if I do it on the left side, I also need to do it on the right side to keep balance. Now let's solve this. Let's simplify this. If I have x plus 2 minus 2, well, that's the inverse, so these go away. In other words, it's 0. And what I'm left with is just x. X is equal to 9 minus 2, or 7. Okay, and like I said before, there's multiple ways I'm doing the same thing, and you'll find the way that works for you. I'll try to do multiple ways of solving equations, but because linear equations are sort of elementary, there's a limited way on solving them because they're linear. So now we have a fraction, and this is going to require a lot more steps. So we want to solve this linear equation. This is actually irrational, but what we want to do is we want to get x by itself. And the best way to do that is to get rid of these denominators. So the way we get rid of these denominators is simply multiplying by that on the top on both sides. So what that means is if I have a 9, let's look at this 9 here. I want to get this out. So the way I actually do that is I'm going to multiply by 9 in the numerator. And I'm also going to do it on the other side, right? Because again, we have to do it on both sides. So multiplying by 9 on both sides. The reason why I multiply by 9 is because if you have something in the numerator and it's equal to the denominator, I can actually just get rid of them like that. And so what I'm left with on the right side is 3x plus 6. On the left side, however, we have something a little more complicated, but it will help us because the right side has been simplified. We're left with 2x minus 4 times 9 is over 3 is equal to 3x plus 6. All right, well, I'm gonna use a property of a fraction, in order to simplify this further. So as you can see, we have something here times something over something. So in other words, if we have something like a times b over b, this is the same exact thing that we have. Sorry, a times b over c. And so if this, let's say that b is equal to 2c, then I'll just replace that using substitution. And what that equals is a times 2. Okay, so if this is called a scale factor. I'm going to use the scale factor in order to simplify this fraction, right? There's 3 3s. There's 3 sets of 3 on the top, which is 9, right? 3 times 3, and then I have a 3 on the bottom, right? So 9 is the same as 3 times 3. Again, you can simplify by crossing out that factor of 3 on both sides. What I'm left with is 3 times the linear equation. All right, now this is just a multiplication problem. I'm going to distribute 3 to 2x and minus 4. 3 times 2x is 6x. 3 times minus 4 is minus 12. Nothing's changed on the right side. Now what do I do here? Again, I want to get x by itself. And there's a couple ways you can go from here. What I start with is the x factors. So I try to get x all on one side, and then I worry about the rest later. So first I have this 3x here. I'm going to actually subtract 3x on both sides. Okay, so these cancel out, and I'm left with 6x minus 3x minus 12 is equal to 6. Well, if I have 6 x's and I have minus 3 x's, then it's the same as saying to take away 3 x's from my 6 x's. So I'm left with just 3 x's. So now I'm close to solving this equation. I just have to get rid of this minus 12 by adding 12 on both sides. These cancel out. I have 3x is equal to 18. And last but not least, we have 3 times x is equal to 18. In order to understand what x is, I have to divide by 3 on both sides. X is equal to 6.